Hello again. In the last video, we we've we've we have found a way to determine the magnitude of the product between two vectors. Now, now in this video, we want to find or determine how to find the actual vector, or in this case we could just find the direction and get the and join the magnitude and the direction into one. Guess you can do that. Alright, let's get some room in the screen and let's draw some vectors. Let's change colors for once. Let's get yellow. Let's zoom in again. Let's get yellow. And let's call this vector A. Vector A. And orange. Vector B. Vector B. In this figure, I'm not going to draw, or maybe I could draw the angle theta. It's still there, of course, no matter what the situation is. So how do you get the direction of the cross product? Well, there's this one thing called the right hand rule. I can't show you my hand right now, so it's going to be hard. I can't draw hands, so I guess you have to follow these steps. I'm going to draw or write the steps. Step one. Step one is place your right hand. I guess place your right hand with your fingers pointing pointing in the direction of the first vector in the cross product. The order matters, of course. So in this direction, you would have your fingers in this case. So point. Man, it's so hard to write. Point fingers in direction of the vector A. In this case, first vector. The let's say this is a sub step, but it's more of a thing you would notice. You would notice that there would be two ways to placing your hand on vector A. You could place your hand like this. I'm going to attempt my best try at drawing a hand. It's gonna look something like this. It's going to look something like this, or so this is going to be where your palm is. Oops, that's not a palm. This is your palm. This is your palm. Or you could do it like this. So you have this way. Oh no, it's not that way, my bad. So that's not your palm. That's going to be your other side of the palm. This is going to be the other side of the palm. Other side of palm. And the other way is this way, where you would have your palm facing in your direction. So I think it would look something like this, where this is your palm This is your palm, this is your thumb, and this is your four other fingers. That's one way to do it. That's that's the way to do it. My bad. The second step is to essentially let's pick another color green. Uh, kind of curl your fingers in such a way that you close the close the gap between vector A and B. So it will in let in this case hmm, in this case if you were to curl your fingers with your other side of the palm pointing towards 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 you, not towards the screen, towards you, you would find difficulty in curling your fingers. You'll essentially have to go 360 to curl your fingers. So this is not this is not the direction of the vector. That's how we determine the direction of the vector. So it's going to be curl your fingers such that such that this ain't writing class, baby, such that vector A closes its gap to vector B. Vector oops, gonna have to write vector B. What's the purpose of this? The purpose of this, let's put it in this color. The purpose of this is to determine which of the two, this is NO, which of the two directions is correct is correct. So this direction is correct. Step number 3. Alright, let's put it in the color of red for joy, I think. Step number 3 is to find where your thumb is pointing. Your thumb would be pointing either up or down. Either up or down. In this case, it's pointing up in terms of it's pointing down. It's pointing down. So step number 3, determine where thumb is pointing is pointing and the direction where the direction of the thumb the direction of the point in the direction of the thumb is the direction of the cross product between the vector A and B. Note, always A first, then B. If it's B first, then A, then it's going to be the opposite. Let's prove that later. So the cross product vector, let's put it in the color color white. Color white is overused. Let's try gold, but it's no different than yellow. It's going to be something like this. This is going to be the vector, and note, and this whole thing is not to scale. Let me try to scale it. Maybe something like this. Small. There. This is straight down, and and the figure may not look like it, but this is perpendicular. This vector, let's call it vector. What's it? Let's call it vector AB. No, 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 no. Let's call it vector X. Let's call it vector X. Vector X is perpendicular to both to both to both vector B and vector A, which means that it's an quote unquote out of dimension vector, I guess, and unquote. How how do we visual? If you don't get uh, what I said was confusing. So let's draw a three-dimensional graph. Actually, I don't need. This is the x-axis, the y and z, and notice that the z-axis is perpendicular to both the x and y-axis, which is analogous to vector x being perpendicular to vector A and B. I guess you would get that. I guess you would get that. Um, that's nice and all, but is there another way to calculate the cross product as as the dot product has another way to calculate the the dot product other than a times b cosine theta? Well, the answer is yes, but first of all, let's prove that b cross a is the negative of a cross b. I was debating to whether I should continue this on another video or not, but why not? B cross a is the negative of a cross b. Now, so b, in this case, b is the first vector, so we would have our right hand point point our fingers point use our right hand and point our fingers in the direction of the first vector. In this case it's vector b. Curl your fingers such that vector b closes its gap to vector a, so it will be this direction. So you would curl your fingers. So you'd notice that up and up would be successful in curling your fingers, and down you would have to turn 360 degrees to curl your fingers. That's not good. You might break your right hand. Don't do that. So um, the so you would also notice that your thumb is pointing in the upwards direction, and coincidentally, not really, up and down are polar opposites. So this is, I guess you can say, an identity. And this rule that I just introduced to you, it's called the right hand rule. See you in the next video.